everyone, and welcome to Discovery's Chats with Changemakers. I'm your host, Tiffany, and I'm a 10th grader in Texas. I participated in Discovery's Future City competition when I was in middle school, and now I'm excited to host Discovery's monthly chats with different guests from the engineering community. Today, our special guest is Murray, an engineer at Bentley Systems. Murray, welcome.
Welcome, Tiffany. Glad to be here.
I'm going to ask Murray a few questions to get to know a little more about him. You can ask questions too by typing in your question in the Q&A box below, and we will save time to answer many. Also, be sure to stay tuned until the end of today's session when we will introduce a hands-on engineering challenge that you can try at home. So Murray, I hear that your job at Bentley Systems helps prevent earth dams from collapsing. How can you tell how stable an earth dam is?
Well, it's a great question. First of all, you can never prevent earth dams from failing completely. I mean, they still fail to this day, but the science has come a long way, is what I would say. I mean, what we try to do is apply math to simulate reality. So the first application of math to try to simulate a landslide was in 1915 in Sweden in the Gothenburg Harbor. And so then we see in 1950s, 60s, they developed the science and the math behind it, but they couldn't solve it because the computers didn't catch up. So then the 80s and the 90s, we saw the computers catch up and the math being put into computers. And so these days it's exciting because now we have really great computing power and we can solve great 3D problems. So we solve slope stability software, and what it gives is a factor of safety of 1.0. means failure conditions. So you don't want that. You want to design it above 1.0. So typically most structures are designed at about a factor of safety of 1.5. And we develop computer models to try to simulate that and to prove that our structure will hit a factor of safety of about 1.5. So that's our target.
So what happens if the factor of safety is too low?
Well, if it's too low, if it goes below 1.0, then theoretically the structure should fail. And so how close we are able to match our computer models to reality is a really relevant point today. And that's what we're in the middle of trying to do, is bring alignment between the computer models and reality.
So if an earth dam is unstable, then what do you do about it?
Well, if it's depends on what type of material is involved. I mean, if there's fine silts involved, you can have what's called as liquefaction. And liquefaction is kind of like when you're walking on the beach and the sand is really hard under your feet, and then you kind of jump up and down and all of a sudden it turns to jello. That's liquefaction, and that can happen in big earth structures. And all of a sudden, if it's liquefaction, they fail, and they can fail in a few seconds and catastrophically. If you have warning that something is going to fail, it starts to slowly creep or deform, then you can load the toe, so put weight on the toe of it. It's called buttressing. Or you can lower the water table either behind the earth structure or in the earth structure through pumping the water out. Water is the biggest cause of slope failures in the world, is changing pore water pressure conditions under the ground.
Okay, so that makes sense how you give the slope extra support with the buttresses and make less chance of collapse by flattening the slopes.
Yeah. So
it sounds like you have a very critical job ensuring the safety of these structures. What kind of tools do you use to catch the errors?
Well, I'm in the side where we're developing computer software to simulate stability. So most of my job is in the office. We're developing software. We're in front of a computer. We're doing that thing. So we've gone out on some site visits and visited them occasionally, or looked at certain failures in the fields or sites. But largely it's office and computer work.
So we have our first audience question. What exactly is an earth dam? Is it different from other types of dams?
Yes, well, you could have concrete dams, then those are a different beast to analyze because the material used is concrete and reinforcing and things like that. So what I particularly deal with is not concrete dam, is earth dams, which are built with soil material. So they're a little more complex because you have not just a single phase material, you have basically soil particles air and water that could be all mixed together in the middle of this structure, and you have to think of how they'll interact from a stress mechanics point of view.
Yeah, it probably makes it a little less stable than like the concrete dams.
They can be just as stable, but there's more variability that you have to account for, is maybe a good way to look at it. Yeah.
Oh, okay. Yeah. So it sounds like you have a fascinating job. What's your favorite thing about your career?
I like the problem solving part of it, actually. Like I enjoy going to figure out and making a computer model, see if it can simulate reality well. I like the problem solving, like some of the forensic analysis, and by forensic I mean where you go into a site after it's failed and you try to figure out why it's failed. Like we were involved with a site called Brumadinho recently in Brazil that failed, and it's very interesting because you go to a site, it failed 3 years after they'd stopped doing anything to it on a bright sunny day at noon. So it raises real questions about, well, why did it fail? Why did it fail 3 years after they were done adding material to it? It's kind of like a bit of detective work that is very fascinating to me. I love it.
Yeah, I could see how it's really important to be able to solve challenges like that.
Yeah.
So, in what ways do you think your job encourages you to be a change maker?
I think right now we are on the cusp of, the classic way of doing this type of engineering was to do a profile, two-dimensional analysis down the middle of a structure and to analyze it and design the whole structure based on that two-dimensional profile. And really now there's access to so much more data in 3D. Like you have drones that you can fly over a structure and map out the surface in detail down to millimeters. And you have access to much better data. And so what it's driving in the industry is a bigger focus on, rather than just a two-dimensional plane, analyzing the whole structure in 3D in a more comprehensive way. And so Bentley is on the forefront of that, and they're using what's called digital twins technology to make a twin of the geotech asset in the field in the computer and replicate it as well as possible over time and bring in instrumentation from the field into your model so you refine it and you make it better over time. So I think the industry is changing in a key way on the analysis going forward, and I'm excited to be a part of that. That's an exciting cusp of development to be involved with.
That's cool. I could see how moving to 3D analysis could make everything so much more accurate.
Yes, yeah, it does generally.
What is something you learned later in your career that you wish you would have known when you were starting out?
Oh, later in the career that I wish I would have known. I think, well, I started my own business, and
Oh, wow.
as in 1997, and I ran it for 23 years. And so I was trained as an engineer, and I always knew, I knew the technical really well, but in the business, knowing the business side and all the HR type of activities that you have to get involved with running a business, that would have been good to know more upfront. And so that's probably my answer. It's pretty good to know more the business side of things and other related aspects to running a business.
Yeah, no, I wouldn't have thought about the importance of business and human resources in engineering, but I mean, that totally makes sense.
Yeah, it comes in a lot of ways. Yeah, go ahead.
Well, so I'd like to transition to some more education and engineering related questions. So, which class that you took in high school is most relevant to the work you do today?
Probably some of the maths or the sciences. And I would still, actually, one of the most useful classes I took was typing. I took typing in high school, which most people wouldn't think was relevant, but it helped me basically program computers. I did that, and I taught myself how to program computers through high school. I had a great teacher in a year I spent in Colorado that taught a class on Pascal, on programming computers, and I loved it. I fell in love with that. And that's what that love later led to me writing my own software and starting a company. And
Yeah,
so,
that's cool.
yeah, neat classes though.
So, what degree did you get in college?
I went through, for me, it was actually a toss off between computer science and engineering. I came close to going into computer science, and I actually started off with a dual degree where I was taking classes in both computer science and engineering. And then I realized that I knew how to program, and there was more mystery for me in the engineering and knowing how things work. And so after 2 years, I dropped the computer science part of it and continued on with engineering. But the computer science helped me get summer jobs and pay my way through school. But I continued on with the engineering through my master's degree, and then in my PhD, I did some classes at Texas A&M. So I did most of my degree up at University of Saskatchewan in Saskatchewan, Canada, and then Texas A&M. So I'm a little bit of a hybrid.
That must have been really hard going through all of those years of schooling and everything.
Yeah, 9 years of schools, but it's the undergrad is hard. I would say that graduate work was quite enjoyable because you get to focus on what you want to do and what you're enjoying, and the classes are not as hard when you're really enjoying and it's interesting and you're taking classes that you want to take and that are fascinating to you. So it flew by.
Yeah, I could see that. So, how did you decide that you wanted to be an engineer?
Well, it was, let's see, I always liked tinkering with things. I liked figuring out how things work. So I was the kid that took apart the family lawnmower just to figure out how it worked. And I wouldn't say that I wanted to be an engineer always since I was young, but basically it just kind of came to me after high school that I liked figuring things out. I liked sciences, I liked maths, and it just seemed like a logical choice when I was looking around. And my father was an influencer on that. He was a professor in geotech engineering for 25 plus years. And so I was familiar with it. He didn't influence me to go into it, but I was familiar with it. And he always commented how much he loved his work and enjoyed it. And so maybe that's subtly influenced me to go into some type of engineering when I later on in life.
Yeah, so if any of our students watching are fascinated with sciences and how things work like you are, then engineering might be a good career for them.
I think so. I think, and I would, if you enjoy figuring things out, if you enjoy problem solving, if you enjoy finding out how things work. I mean, I thought I really enjoyed that actually going through school. It was like you start to figure out how the world works and the sciences and how they've been developed over decades and a long time. It's really quite fascinating to find that out. I enjoyed that part of it.
So we have another audience question. What can happen if an earth dam fails? And why is it, what is an example of why dams are so important?
Well, there's many different types of failure modes. So engineers class failure as the structure is not performing as intended. So that can be on one side of the things where, you know what, it's slowly creeping down and it's deforming enough that, say, the water reservoir dam can't hold water or it's not safe to hold water. So there's not really a catastrophic failure on that hand, just the structure is failing to perform as designed by the engineer. And so you can fix that and you can usually remediate that type of failure. Um, on the other hand, liquefaction failures we mentioned before are probably the most catastrophic because when they fail, everything in the dam turns to basically mud and it flows really quickly. It's like a mudslide. And so those are catastrophic and they tend to follow gravity and end up, it's where they end up is a function of how steep the slope is that they're built on. And they can go anywhere from not at all to they could go miles downstream and have catastrophic results.
Yeah, that sounds like it'd be a very dangerous situation.
Yes, yeah, it is.
So we have another audience question. How much damage can earthquakes cause to earth dams?
Yeah, a lot of damage potentially, and that becomes that's a huge concern with engineering. So if your earth dam is built in a zone that is subject to seismic activity, Usually what we would do is we would have a complementary seismic analysis where in the computer, we simulate the earth dam being subjected to a certain seismic load and see how it performs. So we try to simulate that ahead of time in our designs and account for that, because that's a significant concern. When a dam fails, one of the first things they do is they check all the instrumentation around the site to see if was there a local any seismic activity that could have been a trigger for this failure. So that's a significant concern.
Yes. So what strengths do you have that make you a good engineer?
Probably a lot of tenacity and the dedication to work hard. I would say I've always viewed that I have a lot of determination and a lot of tenacity has been my bigger strengths. I mean, you have to come to the realization when you go through engineering school, you can slip into a mode where you, and maybe this is encouraging for some high school kids, that you think you're pretty smart, and then you go to engineering school and you realize that there's actually a lot of smart people in this world, and some of them are actually smarter than I am. And so that's okay to realize that, because a lot of people that make it through, it's not just being smart, because we had people that were really smart that failed out their first year because they weren't willing to work hard. So I would say that tenacity, the ability to work hard, and the ability to think outside the box and connect point A and B by not necessarily following the direct path has gotten me through in my career.
I could see how those are very necessary qualities of good engineers.
Yes.
So we have a question from Miss Waddle's 8th grade science class that's tuning in today. So her class is studying waves. Does the engineering of a dam take into account wave energy, and how does it change the construction?
That is actually a great question, because, and I remember, I think I asked that question in one of my engineering classes, actually, come to think of it, because it's striking a bit of remembrance for me. But waves, the physical action of waves is not actually of a concern to the design of an earth dam from the sense of affecting the stability, because the earth dam itself is so heavy and so massive that the influence of a mass of a wave hitting the structure is not of concern for the global stability. What it is concerned, what it is of a concern is rather erosional aspect. So a wave can erode an earth dam and then cause a problem where the dam doesn't perform as intended. So what engineers do in that case is they add what's called riprap, or it's basically just gravel and rocks to the upstream side of the dam to break up the energy of the waves. So the waves crash on big rocks. So that's why you'll see in a lot of earth dams, you'll see big rocks, or they'll put scraggy parts of concrete together to just break up the energy of the waves, so that you avoid erosion. But not to be confused with seismic waves. Those are of concern. So if you have seismic waves due to an earthquake moving through the ground, those are a lot of concern to earth dams.
That's interesting how you can use like natural substances like rocks to kind of help the dam out instead of like all man-made structures.
Yeah, some of the solutions to these problems are remarkably practical and just simple. So.
Yeah. So when you were in school, what was the subject that was challenging for you?
Definitely chemistry. Chemistry, and maybe a second was English. I liked reading books. I was a real bookworm, but English was hard to get as good a mark in. I had to work a little harder, and then chemistry was difficult to get through all the equations and to wrap my mind around that. And of course, in engineering in first year, you have to take chemistry 101. And so that was the class I probably had to work the hardest to get a decent grade in.
So it's important to try new things, even if they're hard. Can you tell us about a time you failed at something and what you learned from that experience?
Yeah, I think the main aspect that comes to mind is when, like I alluded to it before, when I got to engineering, I had a good friend that we would all study together in a group, a few of us. And this friend, we would study hard, and this friend wouldn't study as hard, and he would go out and do stuff, and yet he'd come in and he'd get a better mark than everybody else consistently, and it used to bug me. And I remember talking to my dad about this, and he said, you know what, don't, he gave me a great piece of advice. He said, don't worry about what other people get and what they do in life. You can't control that, and it'll just frustrate you anyway. He said, work on what you can control, which is yourself. Study hard, be persistent, and worry about yourself, and your marks will come. And they did over time. And so that's, I mean, there's a health to realizing that you can't be the best at everything, and you can still get through engineering and do extremely well. So
I could see how that would be very frustrating, but I mean, that's some good advice. It sounds like you learned a lot from that.
yes, I did, for sure.
So, what is one piece of advice you would give kids who think they might want to be engineers when they grow up?
Oh, I think if you have an interest in the sciences and you enjoy math, I think don't worry about, I wouldn't put the emphasis on being brilliant. I would put more of an emphasis on being interested and being persistent and being willing to work hard for a goal in your life. If you enjoy figuring out how things work, enjoy the sciences, and you're willing to work hard, then pursue it. I think it can be a rewarding career. And I've loved what I do over the years. It's very interesting.
Definitely. So I'd like to transition to some more like fun and random questions. So what do you do in your free time that helps you unplug from work?
Well, in our family, my mom played the piano really well. So we all of us kids, there's 4 of us. And so I have 3 siblings. We all had to take piano, whether we liked it or not growing up. And I remember giving my mama an absolute hard time about practicing because I just didn't like it growing up. And but I like playing bass guitar, so I latched onto that. And lo and behold, later on in life, so I played the bass guitar in my spare time. Later on in my life, I went to a Bible school in Texas, and there was a guy that played piano just fantastically, and I got interested in that. So I restarted the piano when I was 24 years old, and just practiced hard for a few years, got it up again, and I still enjoy doing that in my spare time. So bass and piano is still a passion of mine, and I enjoy it.
That's cool. So where in the world would you most like to visit that you haven't been to yet?
My kids counted up, and I've been fortunate to go to 14 different countries.
Oh,
so
wow.
far. And so traveling's been a fun part of it. I have never been to Italy or Switzerland, and I've had friends go to those places and tell me they're just very interesting. So those are 2 interesting places that are on the bucket list someday to go to. Maybe do some skiing in Switzerland. That would be fun. Italy just sounds interesting and very European, and the history is very interesting to me.
Definitely. So if you could have any superpower, what would you choose and why?
Well, I've been watching, my son, who is 14, loves watching The Flash. And so I have a secret desire to get work done that fast. And so probably The Flash, if anything.
What's something you've done in your life that you're really proud of?
Well, I'm very proud of my wife and 3 kids. I enjoy their thriving in their own ways with sports and academics that they're doing. And so my oldest one just started college this year, and I'm very proud of that. I'm also very proud of, I started a company in 1997, like I mentioned before, ran it for 23 years and recruited people from all over the world and ended up with about 25 employees. And I'm really proud of that. That was a lot of work, and I've managed to pull together a great team of extremely talented people. So I'm proud of that work.
That's awesome. Do you have any pets?
Yes, we have. Just this last year, we got a puppy whose name is Maggie. She's a golden doodle, and she is a bundle of fun. So she is a great little dog. She loves to play fetch. So pretty much anything you throw for her, she will go and retrieve it and bring it back to you. And she just loves to play. So she's a lot of fun. I had a pet crow growing up. It was probably the
Really?
most unusual thing when I was about your age, Tiffany. And my dad liked animals, so I climbed up a tree and kidnapped a crow and put it under, just before it learned to fly, put it under my jacket, and it adopted us as its parents. And it was the pride and the joy of the neighborhood. Everybody got to know it because it got to know the neighbors. It was really friendly, and it was a great pet to have. Actually, crows have a great sense of personality.
Wow, I've never heard of that before, but that's a cool story.
Yeah, a little different.
Our last question is an audience question. What is your favorite place you visited?
My favorite place I have visited. Oh, I think probably maybe Brazil or Chile. Down south, I've really enjoyed those places, and they just find them very interesting. And so I've been to a lot of exotic places, but those are very interesting places to visit.
Well, I believe that's all the questions I have for you, Murray. So now it's time to introduce our hands-on engineering challenge. Let's watch this Discovery Challenge video featuring Murray.
Hi all, my name is Murray Fredlund and I'm an engineer at Bentley Systems. Today I have a challenge for you. How can you design a way to launch a small ball off the floor so you can catch it? Something like this. Here I have a golf ball, could be something similar. So let's approach this challenge using the engineering design process. Here are the specs. You must only use 1 foot to make your launcher work. Your design must launch the ball upward and high enough for you to catch it. And before you dive in, I have a hint for you, levers. Levers are simple machines. They can turn a small motion into a big one. And they do this by pivoting a long object on a balancing object called a fulcrum. And just as an example, here I have a paper tube and a ruler. So I have a fulcrum and I have a lever. And I can arrange to apply force to one end and throw a small object up into the air. So here are the materials. You need a ping pong ball or a small foam ball to launch. You need paint stirrers or rulers or spoons, all work well as levers. Thread spools or paper tube, towel tubes make a good fulcrum. Tape or rubber bands to hold things together. And feel free to use the other building materials you might find at home. So be creative. The next step is brainstorming your design. Another hint, experiment with your materials and play around with some ideas before you start building. When you're ready, test your launcher. Did it perform as you thought it would? Are there things you want to adjust to make it better and perhaps try again? And the last step of the design process is to share your results. Let us know how you did. And you can email photos to Discovery or post on social media using the hashtag DiscoverEChallenge. So have fun.
I hope that you all will try this hashtag Discovery Challenge and be sure to share your results with us. Thank you, Murray, for introducing this month's challenge and for joining us today.
I've enjoyed myself, and thank you so much, Tiffany.
And thanks to all of you for tuning in. When you leave today, please fill out our survey. And be sure to join us again during Engineers Week for our next Chats with Changemakers. Tune in on Thursday, February 25th at 12 p.m. Eastern Time for a special Introduce a Girl to Engineering Day chat with Joan, an engineer at Collins Aerospace and a former astronaut. Until next time, I hope everyone has a great time trying the Discovery Challenge.